Assalamualaikum. My name is Ahmad Syakir Iman bin Muhammad. My matric number is AE2100229. Firstly, I want to present the introduction. First, introduction to GMAT. GMAT is simulation software for the development and design of electrical device. GMAT incorporates simulation technology to accurately analyze a wide range of physical phenomena that includes complicated geometry, various material properties, and the heat and structure at the center of electromagnetic field. Besides, GMAT is also being used for the development of drive motor for electric vehicles. Next, I want to present permanent magnet synchronous motor, PMSM. Synchronized electric motor is an motor in which the rotation of the shaft is synchronized with the frequency and the AC supply current. The rotation period is exactly equal to an integral number of AC circles. The speed of synchronized motor is determined by the number of magnetic pole and the line frequency. Synchronous motor contain a stator which is electromagnet and rotor that turns in step at the same rate. The synchronous motor have the special properties of maintaining a constant running speed under all conditions of load up to full condition. It is therefore a useful motor is application where the running speed must accurately known by unwavering. Next, permanent magnet synchronous motor, PMSM is a rotating electric machine where the stator is a classic single or three-phase stator like that of a induction motor, and the rotor have permanent magnets. In this respect, the PMSM motor is equivalent to an induction motor, except the rotor magnetic field in case of PMSM is produced by permanent magnet. The use of permanent magnet to generate a sustainable air gap magnetic flux made it possible to design highly efficient PM motor. In this experiment, a single phase PMSM with 2S 2P will be designed and the PM flux characteristic will analyzed. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So today I will explain about the activity 1. So for activity 1, we need to design the parameter of PMSM. PMSM is permanent magnet synchronous motor. So this is the part of PMSM. We have rotor, stator, armature coil, and permanent magnet and shaft. So this is the item before we design the parameter. So there are two parts in designing the PMSM, which is geometry editor and GMAT designer. It is the workflow of the experiment implementation. So first we follow the flow that have been given follow all these steps using the geometry editor and geometry edit designer. This is the step in a rotor design. Firstly, we draw a fraction of rotor. We create a region. Next is the step in stator design. We create the region, mirror, and radial duplications. So the drawing of armature coil and permanent magnet is same from the above. So we just follow on the. So this is the step of armature coil design. You can do it on your own. And this is the steps in permanent magnet design. I will show you the last. I will show you the result of the design. This is the last result of the design. It is a 2D PSNM design. I will show you the last result of the design. Okay. As you can see, this is the last result of our design. Our result contain the model manager and the toolbox. This is important when doing the activity 2. This is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Salim bin Azlan. So today I will explain on how to use the JMAG JMAG designer for activity 2 in experiment 7. So first of all, we need to set the material. So for example, if we want to set the material for rotor, just go at the toolbox and search for example Nippon steel 35H210, and then just drag the material that you want to the component. Same goes with other component. And then next, for condition, also same with how to set the material. So for example, rotor, the motion that we use is rotation, and take the rotation and drag it to the rotor. And then the torque, nodal force, then we drag it to the rotor. Okay, finish for materials and conditions. And then next we need to do the circuit. Which the circuit is have 2 coil, and it is connected to the ground. And then we link the armature coil to the FEM coil. So we link to the coil 1 and coil 2 because we have 2 set of coil. And then click at mesh and we regenerate. And then after that, click if we want to see the magnetic flux flow density, we click study, run active case, save first. So it will run. And then we can click this and we can see the magnetic flux density. Also we can see how is the flow for the magnet flux. Then we can go to the graph and can see the graph of the coil flux linkage. So this is the graph of coil flux linkage versus time. So we have the table of the data for coil 1 and coil 2, and also the time. So I think that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Bahaki bin Yusuf Zaki, and my metric number is AE210034. So today I would like to discuss about activity 3 in the experiment 7, which our group has already conducted in the previous lab session. This activity is the continuation from the activity 1 and activity 2, which need us to sketch up the single phase 2-slot 2-pole permanent magnet synchronous motor PMSM, and do the transient analysis of the PMSM model. Also, in those previous activities, we've already set all the important parts of the PMSM and also some materials and conditions needed for PMSM to work properly. And then in this activity 3, we need to change the 2D model of PMSM into 3D and run the case to see the PMSM work properly or not. So for this activity, we just need to update the condition. For example, we need to add the symmetry boundary of this 3D model, and also we need to add some element size and also the rotation periodic mesh. As you can see, this model is already in 3D, and after we follow all the requirement needed for this 3D model to work properly, lastly we need to run the case, and we can see all the results of the PMSM. For example, this is the result of the coil flux linkage of the PMSM, and also there are some others result such as torque, joule, circuit current, and also FEM coil inductance. As you can see here, the result of FEM coil inductance of PMSM after we run the case. So that's all from me. Thank you.
Assalamualaikum and hi. My name is Ahmad Zairin Ali bin Yaakob. My metric number is DE220103, and today I'm going to present about our group discussion and conclusion. So for our group discussion, permanent magnet synchronous motor, or we can call it PMSM, is a device designed by using permanent magnets embedded in the steel rotor to create a constant magnetic field. This kind of motor is one of the best options for a wide variety of motion control applications. First, a revolving magnetic field is created by the stator winding, which are coupled to an AC source. The rotor poles then lock to the revolving magnetic field at synchronous speed. Next, brushless DC motors and permanent magnet synchronous motors have many similarities, and the most popular type of magnet utilized in these motors is neodymium. There are some advantages and disadvantages of the device. One advantage is that the device can operate with high efficiency and power density. This is due to low heat generation because of the unpresent pressures. Next, the device also works at a low cost, but the initial cost could be high. And then, the disadvantages of the device is it has a complex control system, and two methods of controlling motors are armature current controlling and field current controlling. But in this type of motors, we can change only stator current, and there is only one source in this motor, which is AC supply on the stator. So the only way to control the motor is by controlling the AC supplier on the stator. This needs a complex control system including power electronics and microcontrollers. Okay, so moving on to our conclusion. So for this experiment, we can finally design a single phase 2S2P permanent magnet synchronous motor using JMAC Designer. We gain a new knowledge when do this experiment because before this we don't know about any software like JMAC. And with JMAC Designer, there are many crucial processes involved in designing a single phase to S2P PMSM, including defining the motor's design, selecting suitable materials, and setting up simulations to analyze the motor's electromagnetic behavior. The efficiency, torque density, and overall performance of the motor should all be considered throughout the design process, and several design aspects such as the motor size, the number of poles and faces, the magnet material, and the coil windings have an impact on these variables. And by using JMAC Designer, designers can leverage the software's advanced simulation capabilities to evaluate the motor's performance under various operating conditions and refine the design to optimize its performance. The several analysis tools offered by JMAC Designer, including as magnetic field analysis, thermal analysis, and structural analysis, enable designers to thoroughly assess the motor's behavior and enhance its performance and efficiency. So overall, to design a single-phase 2S2P PMSM using JMAC Designer, various design considerations must be carefully taken into account and advanced simulation tools must be used to optimize the motor's performance. So I think that's all from me. Thank you.